Hi, I'm JD, and what I'm going to be doing today is showing you a little thing about rational functions. So if you would, pause the video and see if you can try this one on your own. Let me read it to you first. It's f of x equals negative 3 over x plus 3. Alright, so first things first, what you can do if you have something like this, either you can use transformations, or what you can do is change it into one rational expression. And let me show you how to do that. First, find the LCD. When you find the LCD, which is here, it's x, multiply the top and the bottom by x, combine them, so now you have negative 3 plus 3x all over x. Now what I would do is I would rearrange it, put both the numerator and the denominator in descending order. So now that becomes 3x minus 3 over x. Now having it in this form is going to show you a couple things. One, it's going to tell you the vertical asymptotes. The vertical asymptotes happen when the denominator is equal to 0. Now also you're going to have horizontal asymptotes or not have an horizontal asymptote, and that depends upon the degrees of both the numerator and the denominator. If the degree is higher in the denominator, you're going to have a horizontal asymptote at y equals 0. If they're the same, like here, then what you're going to have is the leading coefficients over the leading coefficient, both the numerator and denominator, which would be 3 over 1 here. And also if the numerator turns out to be larger, then you don't have a horizontal asymptote, you're going to have a slant asymptote. So let's first start by finding the asymptotes. So let's do the one I mentioned first, which is a horizontal. Asymptote. I'm just going to abbreviate it. So the horizontal asymptote here would be 3 over 1. So it would be y equals 3. Now I'm going to have a vertical asymptote here as well. To find that, you simply set the denominator equal to 0. So x equals 0 would be your vertical asymptote. Now try to find some, now you can test to see, because your vertical asymptotes might also be holes. Well, it's going to be a hole when the numerator and denominator are equal to each other, or both 0. So if you plug the 0 in, is that going to make this whole thing equal to 0? No. So it's not a hole, it's a vertical asymptote. Now what you can do is find your intercepts, if there are intercepts. Your y-intercept happens on the y-axis. Here, that's an asymptote. So you're not going to have a y-intercept. So none. Now, you're going to have, also you plug it in, 0 for x, and you get undefined, you get this whole thing being undefined, so you're not going to have a y-intercept. However, you're going to have an x-intercept here. Just set the numerator equal to 0, so you have 3x minus 3 equals 0, and then just solve for x. So you add 3 to both sides, so it's 3x equals 3, divide both sides by 3, so x equals 1. So you have an x-intercept at 1, so it would be 1 comma 0. So I'm going to erase this. Now what else you can do to graph is just plot some points. So for example, if I plug in 1, that's that's going to cancel. Now also, like you want to think through, okay, what can I plug in so that it will divide evenly? So try like -3, +3. So if I plug those in, -3 and 3, I can plug them either into here or here. I'll plug them into here. Let me erase those real quick. So if I plug in -3, -3 over -3 is 1, and 1 plus 3 is 4. I plug in -3, or sorry, +3, so it's -3 over +3, which is -1 plus 3. -1 plus 3 is 2. Now I plug in, let's plug in a -1. If I plug in a -1, that's -3 over -1, which is a +3. So 3 plus 3 is 6. So that gives me a good idea on how the graph is going to look like. First, plot the asymptotes. So you have a horizontal asymptote at y equals 3. One, 2, 3. That's your horizontal asymptote. Then you're also going to have a vertical asymptote, and that's going to be on top of the y-axis. That's x equals 0. So plot your points. You have an x-intercept at 1. You also have a point 3, 2. That's right there. You also have -1, 6. 3, 4, 5, 6. Right there. -3, 4, which is right here. So that gives me enough points to kind of find the basic shape of it. Now asymptotes, you're going to have the function, and they get closer and closer to the asymptotes, but they never touch. So that's one part of the graph, and then you're going to have another one that's going to go like this. Gets closer and closer to that horizontal asymptote, but it never touches. All right, and that's it. And that's how you graph a rational function.